Welcome to question 18 from the 2020 CTMUA, paper 1. The question asks us to find the number of solutions and the sum of the solutions to the equation 1 minus 2 cos squared x is equal to the absolute value of cos x, where x is between 0 and 180 degrees inclusive. We are given 6 different possibilities for the answer. Pause the video, read through these options and try to solve this question for yourself. Okay, well, we can see there's 2 possibilities for this equation, because when we take the absolute value of something, it's either going to be equal to cos x if cos x is greater than or equal to 0, or it's going to be equal to minus cos x if cos x is negative. So we can therefore write this down as 2 different cases. We'll call the case where cos x is greater than or equal to 0, case 1, and the other case 2. So now we can try and solve these 2 equations individually, and then that will give us the solution to this overall equation. So firstly, let's look at case 1, and we can rewrite this equation as 2 cos squared x plus cos x minus 1 equals 0. So we can see that this is just a quadratic in cos x, and we know that all our solutions must satisfy cos x greater than or equal to 0. That's our condition. So how can we solve this? Well, since it's a quadratic, we can use whatever technique we want. I'm going to factorise this, so that gives us 2 cos x minus 1 times by cos x plus 1 equals 0, and therefore we can see the solutions to this equation are cos x equals half or cos x equals minus 1. However, the condition in case 1 is that cos x is to be greater than or equal to 0, so we can see cos x can't equal minus 1. So the solution in case 1 is just cos x equals a half. Now can we similarly do the same thing with case 2? Well, yes, we can again rewrite the equation here for case 2. We have now 2 cos squared x minus 1 equals 0, just by putting everything on one side of the equation. And we're working with the condition cos x is negative. So again, this is a quadratic in cos x, so we can solve it with any of the techniques we want, the quadratic formula, completing the square, or factorising. I will factorise here, and that gives us 2 cos x plus 1 times by cos x minus 1. It's equal to 0. So we can see the solutions to this equation are cos x equals minus a half or 1. But since we're working with cos x being negative, we can see that cos x can't equal 1. So in case 1, the solution is cos x is a half, and in case 2, the solution is cos x is minus a half. So these are all the possible cases, so therefore the 2 solutions to the equation given in the question are cos x equals a half or minus a half. But we now need to find the number of solutions this means there are for x, and the sum of those solutions. So let's do that on the new page. Okay, so we've identified the solutions are at cos x equals a half and minus a half. So let's try and draw a graph of cos x and think about where these points are. So if we label x points up to 360 degrees, then we can draw a full cos wave in, which looks like this, and oscillates between 1 and minus 1. And we're told in the question that we only care about x values from 0 to 180 degrees. So let's put a dotted line here. We're only caring about values in this region here. And we want to solve cos x equals a half or minus a half on x values in this region. So if we draw in a line at a half and a minus a half, we can see that there is one intercept between cos x and a half here, and one intercept between cos x and minus a half here. So therefore that tells us that there are 2 possible solutions for x, and we now need to find what those solutions are. So we need to find a value of x between 0 and 90 degrees, which has cos x equal a half, and a value of x between 90 degrees and 180 degrees, which has cos x equals minus a half. So you might know the value of x that satisfies cos x equals a half. And there's a way we can find that. If we think about an equilateral triangle with side length 1, and then we split its base in half with a 90-degree angle, then each side of this will have length a half, and therefore cos of 60 degrees is equal to the adjacent, a half, divided by the hypotenuse 1. So cos of 60 degrees is equal to a half. So we can therefore see that x equals 60 degrees is this solution here. But what's this solution here? Well, by the symmetry of the graph of cos x, we can see that that point will actually be at 180 degrees minus 60 degrees, because we've just come along as far here as we have to go back here from 180 degrees. And therefore that means the two solutions are 60 degrees or 120 degrees. So we know there are two solutions and we know what the solutions are, and the question asked us to find the number of solutions and the sum of the solutions. So therefore the sum of the solutions is 60 plus 120, which is 180. So we see there are two solutions and their sum is 180 degrees, and if we check back to the options at the start of the question, you can see that that was option A. So our answer is A.